Hi guys, our topic for today is quadrature amplitude modulation. What is QAM? QAM is both an analog and digital modulation scheme. It conveys two analog message signals or two digital bit streams by changing amplitude of two carrier waves. Using the amplitude shift keying ASK, digital modulation scheme or amplitude modulation scheme for analog modulation. Analog QAM. The QAM is similar to DSB-SC but sends two message signals over the same spectrum. One of these message signals says M1 is sent in phase by multiplying it with cosine WCT, and in the other's message signal, M2 is sent in quadrature by multiplying it with sine WCT, and finally adding these two signals. This is the example of QAM transmitter. QAM constellation. In M-ARI PSK modulation, the amplitude of transmitted signal was constrained to remain constant, thereby yielding a circular constellation. By allowing the amplitude to also vary with the phase we obtain in QAM, so constellation consists of a square lattice of signal points. These are the example of 16-ARI QAM, and the other side is 8-ARI QAM. QAM bits per symbol. The advantage of using QAM is that it is higher order form of a modulation, and as a result, it is able to carry more bits of information per symbol. By selecting a higher order format of QAM, the data rate of a link can be increased. This is the example of modulation that have bits per symbol and symbol rate. The advantages and disadvantages of QAM. QAM increase the efficiency of transmission for radio communication system by utilizing both amplitude and phase variation. It has a number of drawbacks. The first is that it is more susceptible to noise. Receiver for use with phase or frequency modulation are both able to use limiting amplifiers that are able to remove any amplitude noise and thereby improve the noise realance. This is not the case with QAM. The second limitation is also associated with the amplitude component of the signal. When a phase or frequency modulated signal is amplified in a radio transmitter, there is no need to use linear amplifiers, whereas when using QAM that contains an amplitude component, linearity must be maintained. Unfortunately, linear amplifiers are less efficient and consume more power, and this make them less attractive for mobile application. Almost always requires a highly stable local oscillator. In the optical domain, this is very expensive. And that's it. Thank you for watching, guys.